Yeah, we're streaming.
Cool. So today I'm supposed to talk about something I'm not that comfortable with, which is always fun, which is debugging or graphics debugging. I've done some, but there are probably people in this room that have done sort of more. So if anyone knows anything, then it's really great if you could sort of raise your hand and add tips or whatever when you go into it. But I'm basically going to give a sort of super simple introduction to RenderDoc, which is graphics debugging tools that I've used a bit at least. So sort of a newbie introduction to how do you set it up and how can you inspect certain bits. And then we're going to use the sort of second half of the lecture to look at IMGUI, and with that the introspection tools that I've written up for this course, and also how you can then use IMGUI to create sort of simple UI elements that can also help you in debugging your own stuff. So if there's any question, please just sort of throw them out, and I'll try as best as I can to answer them, but I can't sort of guarantee anything. We can then probably just start with RenderDoc. Has anyone used RenderDoc before? Okay, you two have used RenderDoc before. So you who haven't used it before, do you know what it is? Like, have you heard the name?
Heard the name, don't know what it is.
Okay, cool. So RenderDoc is sort of you're using it to sort of debug graphics programs, because as you've probably seen already, it's not sort of as trivial to debug graphics programs as sort of regular programs. It's not, you can't necessarily set breakpoints the same way, because you're not really setting breakpoints on your GPU, etc. So a lot of that is sort of figuring out what state is your GPU currently in. And RenderDoc can help you doing that by sort of allowing you to capture basically sort of frames of your application. We essentially sort of take screenshots, which also contains information about the OpenGL calls you used and what the state was at that time. So you can sort of really easily go and check, when I drew this rectangle, what sort of was the state of OpenGL at that time. Yeah, so I'm just going to show off quickly how to set it up. So you need to obviously download it. It runs on both Linux and Windows, and probably also Mac, I assume. I never tested. But there are also other tools that sort of work similarly, like CodeXL has been mentioned. All of these different tools also sort of come with different variations on what they can really help with and whatnot. Like I did use CodeXL at one point, but I found that RenderDoc sort of fit my needs better. But there are other issues that I would go and look at CodeXL for sort of instead. But for just sort of figuring out what's being rendered over to the screen or picking up on errors, etc., that's when I bring up RenderDoc if I can't figure that out sort of instantly myself. So the way you use RenderDoc is that you obviously download and install it, and then you start it up, which will bring you to this sort of screen, where you should have a launch application sort of a tab, and can set up some different variables for like the execution path, the working directory, etc. So we're going to just launch a really simple program, which is the testing program I use for the GFX stuff that you're supposed to get. It's not really that impressive, it's just, a smiley. It's basically me just setting up the bare bones stuff I need to test this, which I will be talking about later. But it's just smiling. So what we'll do is that we'll set the executable path to where we have built up application. In my case, it's sort of, we start at the top, go through school, and then go to, our graphics programming place and our build folder and the main. So that's sort of the main executable. You'll notice that we also need to set up a working directory. That's essentially where essentially from where you deal with relative paths in your program, if that's the correct way of saying it. So, you know, when you usually load a file, you can say like that you want to load the file like /text.txt, and then that file will be loaded from the relative / or where your program sort of was started, or what's the working directory of the program. I don't know what's the our common working directory. Is that the build folder, or is that the outer folder again? For the labs?
It's the build folder.
It's the build folder, okay. So in my case, it's not the build folder, it's one level out. So that means I set up the working directory to be just like graphics program.
That's the case, yeah.
Okay, that's the case in the labs as well. Okay, so then you all know that the working directory is, in the labs, the working directory is sort of the directory above the build directory.
Well, maybe not actually.
We'll figure it out. Like, you will be told if you do it wrong. Your program will crash or whatever because it can't like find the image that you're trying to load for your textures or something. So you'll find it out one way or another. And yeah, and then you can essentially just launch your program. And you'll see that suddenly we got this text up here where it says like OpenGL, press F12 to print screen to capture frame, and then it says the frame count and the like average FPS, how many captures we've saved so far, and the number of chunks. Never used it, so don't know. So what we'll do then is that we'll press F12, and in the background here we suddenly got like a capture collected, which is an image of the sort of what everything was looking at that point. So we can double click that, and once we double click it, we sort of load it up to say that that's what we want to focus on. And suddenly we can sort of make use of all of the cool tabs that we have here. So we can look at the pipeline state. Essentially what happens is that, as you can see here, that we have the start our frame here, and then this is where we call our swap buffers. So everything like this is the clear, and then that's the actual sort of displaying of stuff. So you have all your draw commands, hopefully, between those two. So what we can see here, and this is the color path, so this is where we draw all our elements. And you see here that here we're doing the clear color, and then we're starting to draw different elements. So here we draw something that's sort of 6 long, which, something that has 6 vertices. And then further and further, we sort of draw different items. Like all of these are sort of just for in GUI, so we'll ignore those for the moment, because this is the one that we want to focus on. When you're drawing a lot of stuff, it might be hard, at least in the beginning, to figure out which item you're actually supposed to inspect. However, you can go to the texture viewer and sort of see that at this point then nothing is drawn, and then we draw this element, then the next one, and the next one, next one, next one, etc., etc. So we can quickly identify that that's the one we want to draw if we're trying to figure out how sort of the smiley is drawn. But we can go and look at the pipeline state. So here is some of the vertex attributes that I'm sending in to the shader. So if we go into our shader, you can see here that we're getting in these 2 variables. Ignore all the uniforms for the moment. They're just there for me sort of testing stuff. But yeah, you can add this in here, and then you can also see here that they're sort of down here. You can see which buffers they belong to. And here you can go and inspect the buffer, like the element buffer. If we go to it, then we can see that we have the indices, which comes in sort of 3 and 3. So that the way we draw this is like first 0, then 3, then 1, then 1, then 2, then 3. Yeah. And the same can be done with like the buffers. So here you can see all the positions, and then padding. 2 seconds. Because we're drawing with the interleaved one. Yeah, so it just tears as padding, but I'm going to assume that those are floats. So down here you can write the format that you want to. It's really small, so you probably can't see, but you know you can write the format that you want to visualize the buffer in. So if you have like interleaved your buffers, so in my case I have first I have both the positions and then the texture coordinates, and I know that that's, you know, it's first 3 floats and then it's 2 floats. So then you can write it up here so that you get it formatted correctly. Right? Any questions? Everyone understanding everything? Cool. So yeah, so that's how you can sort of inspect the different objects. However, if they have like way crazy positions, that's not always as easy to sort of understand. So we also have this mesh view, where you can again see what's coming in, and then you can look at the drawing of the object as it's happening. So as you can see here, you can see that this is, you know, our 2 triangles, and if we turn on the highlight vertices, we can see which vertices we're currently working on, and you can click yourself down, or as you click yourself down, you can see which vertices they're drawing. So you have the little blue square here. That's because that's the first vertex, and then that's next one, and then we draw next one down here, and then we draw the other triangle where we sort of go through the steps. So we didn't actually have this tool when I did graphics programming, but when I sort of came back looking at graphics and picked it up, this like massively helped me understand what was actually happening. Like being able to sort of step through that is really, really great. And you can sort of also change, like, do you want wireframes turned on? And wireframes are sort of drawing just the lines.
So that smiley face, is it put as a texture on those triangles?
Yeah, in the end it is. But that happens in the fragment shader, if I don't remember wrong. And the cool thing is that you can also sort of rotate and move a bit around within this application. So for instance, you can use WASD to sort of move around. That is just like a godsend if you don't know where your objects end up. And that's happened to me before, that I've, you know, done some math and suddenly stuff doesn't appear on screen. And it might be that I messed up, that I was doing like thinking that positive z-axis was the opposite of what it actually was. So the objects ended up behind me, which is, you know, really hard to debug in application, because when you then turn around, stuff aren't necessarily working. If you can turn around, it might be, in my case, I didn't actually have sort of camera functionality built into the application yet because it was so early. And then being able to sort of look around to see if something's behind you is massively, you know, that helps. And you can also add in, if you look, so this is what we get into the vertex shader. This is what we get out of the vertex shader. And you can also add in, like, do you want to add in the whole pass? Then you get sort of the interactive, or the mode where you're shown how everything is drawn on screen, like we show in the texture. That, you know, first we draw the rectangle holding a smiley face, then we add in the GUI stuff, and yeah, again, you can sort of, you know, look around to see how stuff is working. And also for sort of geometry shaders, but I guess you're not getting into that. So yeah, so use these tools, and if you suddenly notice, like I did now, that, you know, I'm clicking around, but we're not sort of moving the square on top here, showing which vertices we're working on. That's the sync views. Yeah, so that you can sort of click and then see what which part you're working with. Any questions? No? Cool. You can also get statistics. I haven't used that much, so much of them yet. Sort of the texture view. That's actually quite, like, you can look at the different, well, you have stuff, looking at sort of the inputs and outputs, and looking at everything from like alpha values, etc., etc. I'm not that proficient with RenderDoc yet, but what I've been using it for so far has mainly sort of been to find out where my vertices sort of messes up. You also have sort of an overview over all the buffers that you're using and what data exists within them in the resource inspector, and you can also get access to that sort of by looking over here. Additionally, let's see if there's anything else. Yeah, and you can also go and look at your sort of which shaders you actually have compiled and read the source for them. And also you'll have this window called errors and warnings. Please read that. Like if you have errors or warnings, that's something you should sort of look into. You'll see in the bottom here, there's like a green check mark. If there's something wrong, it will like blink with like a stop sign. Which means that you probably have a warning or an error. So go in and check what that is and try to figure out how you can fix it. However, you might end up with a lot of like trash warnings, at least know that I did, where which is basically when you get sort of like info stuff that suddenly shows up as warnings, like I was allocating some buffers through like GL gen buffers and giving them some data, and then suddenly like I got a lot of warning messages stating which type of storage that the GPU would use. Like for this buffer, then the GPU will use this this sort of storage, which from my understanding is more sort of performance and maintenance type of warning and not something I cared about at all. I also think if you look at the Learn OpenGL tutorials, when they sort of help you to set up debug message callbacks, etc., those are among the ones that they'll like explicitly ignore because it's not that useful. But most of the time, you're really interested in sort of figuring out what's going on if you get an error or warning. You can also sort of queue up multiple captures. So we can say that I want to like capture 5 sequential frames up here, and when you've sort of started the application, and then you just click, and now you suddenly get 5 frames that you can sort of inspect. So if you're what you can do, and you can also set delays for those. So what you can do is that, like, if you have some stuff that, for instance, you're when you're running your application, suddenly everything starts rendering incorrectly after you press a button because you're doing something, then you can set up a delay and start capturing stuff. And once the delay is sort of out, you press your button. So say like wait a second and then capture 100 frames. So you'll just sort of say, start capturing it and then press the button so that you can get frame captures of the exact place when your application sort of messed up. It's also possible to do this during startup by sort of saying that you want to queue captures. So we'll go in actions here and say that we want to queue captures from frame 0, and we want to queue 5 frames. And run it. However, that's really useful, but I think there's a bug in RenderDoc here. At least it doesn't work the way I expect it to, which is that for some reason I'm constantly told that that I haven't bound any index buffer stuff when I'm doing my index draw. Which I think I spent a lot of time looking at that yesterday and trying to debug it, and my conclusion is that I think there's a bug in RenderDoc because I've sort of really nailed stuff down, and I think I'm doing it correctly. So just sort of be aware, because you also found a bug in RenderDoc yesterday. So, as like everything, this is a tool, and you know, it's super great, but it's complicated. So bugs can happen. Just sort of be aware of that. Most of the time, it will probably be you, but it might also be that, you know, the software is buggy. And I sort of wasted, I think, 4 hours on figuring that out yesterday. So just sort of be aware. Cool. I don't think I can do 2 hours today.
No, you shouldn't. So and that's cross all platform anyway, right?
Yeah, I think so.
Yeah.
Yes, I think that's the most important part of RenderDoc, unless there's, for you two who's actually been using it, is there any functionality that I haven't showed off that you think should be mentioned?
Maybe that you can use the resource inspector to look at textures as well to see if they loaded correctly.
Ah, cool. So, yeah, that's the, which one?
Just
there we go,
any texture and view contents in the top right.
Right, yeah. Yeah, so that's resource inspector, and then finding, you know, your actual texture, and then clicking on view contents. Yeah. Any questions about RenderDoc?
Did anyone try Code XL before? I think it's created by AMD, right? The Code XL.
Yeah, but apparently you can run it with other cards as well. But apparently it gives you a sort of...
Yeah, it gives you a warning every time you start it up.
Yeah. And it's proprietary, right? Where this one is open source, right? RenderDoc.
Yeah, but in general, AMD is quite nice when it comes to that sort of stuff. So, like, a lot of their tools are open source, and they usually support other platforms as well.
Right.
It's usually the other way that it's NVIDIA that sort of varies a bit on that part.
That apples around a bit.
Yeah. So cool. So like, learn to use this, and preferably learn to use this like now, because it's really annoying trying to sort of wrap your head around how it works when you've messed up. Then it's too late. Like, you can, but that's a massive, you know, amount of time that you suddenly spent learning a tool when you were actually trying to fix an issue.
Yeah. Well, especially true for the with respect to the bugs that the tool may have itself, right?
Yeah.
So if you have a known executable, right, and you see known errors, right, which are apparently not really helpful, then at least you can distinguish it easier than having a non-running, you know, version of your game or something, and then trying to delineate as to whether that error is actually because you messed up or whether it's RenderDoc itself, right? So it's quite helpful indeed.
Like, if I knew that there possibly was a sort of startup bug in it, when you're sort of queuing up frames when you started, if that's a bug, again, I haven't actually confirmed that that's a bug, that's just like my main suspicion at the moment, but if I had sort of knew that from the start, then I wouldn't have wasted so much time yesterday. Yeah. So, you know, download it, start running it, and start just experimenting. Like, look around at what's happening. You're working with sort of data that you've captured, so you won't destroy anything by, you know, looking at stuff.
It's just reading from snapshots anyway, right? So it's not doing anything. You can't inject data or change, you know, affect the runtime at all, right?
Yeah.
It's just working offline basically.
Yeah, and you can even, like, you don't need to, like, as soon as you have you captured, you can terminate your program. So, you know, you're capturing the state of OpenGL at that point. You're not interacting with the application. So sort of some other stuff that I have noticed that's been a bit weird is that you can apparently do like remote debugging with this thing, which is quite cool. However, there are some issues here and there. So for instance, yesterday I was queuing up that I wanted to catch 5 frames, and then suddenly it said, like, you know, frame 1 is okay, frame 2 is okay, frame 3 is a remote debugging call, and that's also frame 4 is remote debugging, and then frame 5 is, you know, back to being okay again. So I don't know how it sort of managed to come up with that, so that view of the world, but, you know, that's and then you might get some sort of warnings on that, you know, you can't delete stuff from a remote debugging procedure, and then you're sitting there going, well, I wasn't debugging stuff remotely, so yeah. So, you know, there are issues, as with essentially every tool, but still the sort of in general the quality of it far outweighs any problems that you might run into. Cool. And so, for instance, here you'll see that since I now queued up the 5 frames that were when we started the application, this is the bug I spent a lot of time yesterday. Is that it says that that there's no index buffer bound at the index row, and it says here sort of which ID it was, which is a bit hard to see because usually this window sort of scrolls over here. But you can see here that it talks about, this is the ID that we're talking about, I guess it's event ID or something that it stands for. So, it happened at 0.5. So then I can go back and check, okay, where did that error come from? And then try to figure out which draw call I did where I managed to get that problem. And what you'll see here is that since they're saying that I haven't bound any index draw call, then I also can't inspect my pipeline state properly because it doesn't know. Here it doesn't actually say that I've bound all the buffers that I bound. So yeah, so be mindful that there might be issues in the program. Cool. And experiment around with sort of looking at how this thing actually works.
Do you have a more complex example you could load for the sake of it? Like, I don't know. No? Okay. Good.
Well, I mean, it's the IMGUI stuff, but that's sort of...
Yeah, no, that doesn't help debugging a framework right now.
No.
I'm just thinking as a general example of any graphics executable, just to appreciate the complexity.
Do you have a game installed?
Not on Linux.
Okay.
I'll see, but I don't think I have any. No, I don't have any sort of more.
Or your graphics exam, yes. Great.
Well, the problem is that I think that's Windows. It's Windows only.
Okay.
So sorry about that, but
No,
no,
fair
I don't have anything sort of showing it off. That means that you get the experience of trying to do that.
Yeah.
Cool. So
this one can be actually useful for the assignments, right?
yeah,
Yeah, of course.
yeah. Use it for the assignments. Use it for sort of everything. Obviously, the sort of main, I guess, problem with this is that it sort of requires you to run it when you're running the application and etc. So, you're not fixing it in runtime or necessarily inspecting stuff at runtime, which is hopefully where the GFX tools can help a bit. So I guess I can just start showing them off.
Are there any more questions from you guys?
Yeah, before I jump over to a different topic.
Now's the time. I mean, I think one of the messages here strongly encouraging to download this thing as soon as possible.
Random.org.
Yep.
Sure.
I was confident.
I mean,
Random.ru.
Random.org. Like that page.
I'll send you a link.
Yeah, just say the link. So CodeXL kind of probably also just pointed out, so people can run both actually if they want to, just for the sake of it, because it's quite similar in terms. Well, it's different, but it has certain other features. But just to be comfortable with the web page, so that's how it looks like. So you can download from there as well, and it's slightly different, but it has very similar feature sets. And apart from the annoying arrow at the beginning.
Yeah.
I guess it's fine if you have
AMD, you're sweet, yes.
Yeah. But yeah, that's all, I think I don't know if you get profiling from RenderDoc, but at the same time, you guys shouldn't really be worrying about that shit. But yeah, like this, CodeXL also is like a really great sort of tool suite. But I found that in 99% of the cases, RenderDoc is everything I need. Cool. But I still sort of suggest people download more of them, just to sort of get familiar with as many tools as possible. And if you find a great tool, please share them with the rest of the class.
think it's valuable. I think it's in the end it's about finding the tool that works best for you in the end, right? So it may be Render, maybe Code XL. So just be comfortable with this, because in the end, you know, it may be the difference to you finding your bug faster, right? And that may matter in certain circumstances. So just play around and see.
I think there's a cool tool, NVIDIA Insight, but I haven't used it.
But that's
That's a profiling tool, I think.
yeah, I also think that. I think that's like you need Visual Studio.
Yeah, it's
to
for
run
Visual
that?
Studio.
No, I mean, do you need the NVIDIA card to run that?
I think it's for Visual Studio also.
Yeah, but you need it's
It's definitely for NVIDIA only.
yeah, it's NVIDIA only. So if you have an AMD, then you're fucked.
But if
yeah.
you have an NVIDIA graphics card, you totally use it. Or
Probably. Like, there's a bunch of different tools. Like, in general, there's a bunch of tools out there that can help you with stuff. Also, like, to sort of go outside the graphics for a moment, there's also a bunch of other tools that you should probably check out. I know I just downloaded the Intel sort of system suite, because they now suddenly, from my understanding, essentially gave away sort of the whole suite for free if you're like don't earn that much, etc. And that's like you know, industry grade profiling tool that are used by like a lot of game studios, etc. for performance tuning. So go and sort of look at those sort of tools and familiarize yourself with them, because it's really helpful to know, not just in graphics but in other places as well. Like, look into static analysis tools, look into profiling tools, etc. So,
cool.
Should we take a break before I start?
Yeah, probably sensible. Huh?
Yep.
So 10 minutes or 15? What
Yep.
is
10?
10?
So
Okay.
remember, they're back by 3.
Yeah. Okay. 3 o'clock.
Just one more thing before we go, for the people, because I know some people are leaving after this hour. So I'm giving out the GFX tools, and I'm going to talk about them the next hour. However, I have found one bug with using them together with RenderDoc, which I assume is my fault, and I'm looking into sort of the problem in general, because there seems to be more going on. So when you're using, I can just actually show it. So if we launch our application, so one of the things that I've done is create sort of an introspection program that I'll be talking more about after the break. Essentially, it allows you to sort of inspect your different buffer objects, etc. Again, I'll go into it. The only thing that you need to know now is that when running the program through RenderDoc, and you try, like, don't trust the data that you get out from your element array buffer, or that I say that I get out from the element array buffer, because that's like horrendously wrong on all levels. When you're running through RenderDoc, if you're running the application as a standalone, it works fine, hopefully.
Okay.
Like, it works fine so far. Then we'll see how much it breaks when you guys start working it. But just sort of keep that in mind, that, you know, you can see here that, like, as I'm changing different stuff, the values are also changing in the EVO. So obviously there's something going on here. Cool. Then you can take a break.